Hello students, now let us continue with the method of separation of variables. I'll discuss some more problems, how to solve a differential equation by the method of separation of variables. So like in this example, I think the notes I've already sent through PDF. So here as you can see this example, solve x plus y the whole square into dy dx is equal to a square. So we name this equation as equation 1. So in this case it is not possible to separate the x and y variables separately. So what we do is it is not possible to separate the variables. So what we do is we use the method of direct substitution of x plus y by some variable, say z. So here we substitute x plus y by z, and from here we can separate the variables separately. So what we do here is put x plus y is equal to z. The question is x plus y the whole square dy dx. Now if you differentiate this with respect to x, what we get is dx gives you 1 plus dy dx is equal to dz dx. So this implies that bring this 1 to the left hand side, it becomes dy dx is equal to dz dx minus 1. Therefore equation 1, what is equation 1? Equation 1 is this: you replace x plus y by z, so it becomes z square, and dy dx by this dz dx minus 1. So therefore 1 reduces to z square into dz dx minus 1 equal to a square. Or now you divide both sides by z square here. So you have dz dx minus, that is dz dx minus 1 is equal to a square by z square. Or bring this 1 to the right hand side, will become plus. So you have dz dx is equal to 1 plus a square by z square. From here it implies that dz dx is equal to z square plus a square divided by z square, which implies that now you can separate these variables, so the z and x variables separately, or so that you can write here dx is equal to z square by z square plus a square into dz. So where the x and z variables are separated. Now you can integrate this. From the left hand side you will get x only, whereas from the right hand side this can be written as, we split it. So z square by z square plus a square is same as 1 minus a square by z square plus a square into dz, as you can see on the right hand side of the copy also. 1 minus a square by z square plus a square is equal to z square plus a and a square get cancelled. So what it means here, it is nothing but z square by a square, z square plus a square. Now you integrate this, you can integrate it now into two parts: integral of dz minus integral of a square by z square plus a square. So a square you can take it outside. So we have x is equal to integral of dz minus integral of a square into dz by z square plus a square. But integral of dz by z square plus a square here is nothing but 1 upon a into tan inverse of z by a. So therefore you replace, now what we get from the integration is x is equal to z minus a, because this a square from here will get cancelled with this 1a from here, from the integral of dz by z square plus a square. So what we have here, it is z minus a tan inverse of z by a plus c. But the original equation is in terms of x and y. So what we do is you replace again this z in terms of x plus y. So if we replace it in terms of x and y, what we get here is x here will be equal to, instead of z, you write it as x plus y minus a into tan inverse of z. So instead of tan inverse of z, you write it as x plus y divided by a plus c. Now if you bring the whole term, okay, this now bring this to one side, let y remain on one side. So you have y is equal to x minus x, because this x and this x, they are on the opposite side, so they can get cancelled. So this implies that y is equal to a into tan inverse of x plus y by a is minus c is the required solution. One more problem is solve sine inverse of dy dx is equal to x plus y. So here sine inverse of dy dx is equal to x plus y. By applying sine on both sides, this implies that sine into sine inverse give you identity function. So you get dy dx is equal to sine of x plus y. Now again, this is not possible to separate the variables. So what we do is we use that method of substitution. You replace x plus y by u or z. So differentiate this with respect to x. What we get is 1 plus dy dx is equal to du dx, or dy dx is equal to du dx minus 1. Replace it in 1. So what we get is du dx minus 1 is equal to sine u, or du dx is equal to 1 plus sine u. So as you can see here, the x and the u variables can be separated. Now solve this using the method of separation of variables. So we have du by 1 plus sine u is equal to dx. So you can integrate them separately, the x and u variables. Integral of du by 1 plus u is equal to integral of dx. Or now, as in this case, what we do is you multiply both numerator and denominator by the conjugate of this. Conjugate of 1 plus sine u is nothing but 1 minus sine u. So you multiply here both numerator and denominator by 1 minus sine u, so that they will get cancelled, which is the same as this one only. But we know that a minus b into a plus b is nothing but a square minus b square. So therefore 1 plus sine u into 1 minus sine u is equal to 1 minus sine square u, and from the numerator 1 minus sine u will remain as it is, equal to integral of dx from the right hand side. But 1 minus sine square u here is nothing but, because sine square x plus cos square x gives you 1, so therefore 1 minus sine square u is equal to cos square u. So you replace this by 1 minus sine square u by cos square u du. So what we have here is, or integral of 1 by cos square u minus sine u by cos square u du is equal to integral of dx. So integral of du 1 upon cos square u is nothing but secant square u, and sine u by cos u you can write it as tan u, and 1 by cos u is equal to secant u. So you can see here I've already given the reason why this part is equal to this. Now integral of tan square, secant square u is nothing but tan u only from the standard integration, and integral of secant u into tan u is nothing but secant u is equal to x plus c. But u is replace the original equation is in terms of x and y, so you replace u as x plus y. Therefore the required equation will be tan x plus y minus secant x plus y is equal to x plus c will be the required equation. Similarly, with the remaining problems also, the same thing with this next problem, that is cos of x plus y. You replace this by u and apply the same method. You can separate the variables x and u separately, but at last you have to convert it again to the original equation in terms of x and y. So this one is not in the form of substitution where you can separate the x and y variables separately directly. So here we have y minus x into dy dx is equal to a into y square plus dy dx. So what you do is y minus x dy dx is equal to a into y square plus dy dx, or you can bring this a y square to the left hand side, it will become minus ay square. This minus x dy dx, bring it to the right hand side, it will become x into dy dx plus a into dy dx. So you can take dy dx common. So or you can write here dx, you can separate the x and y variables separately, cross multiply this and bring this to this side. So we have dx by x plus a is equal to dy by y minus a is equal to 1 upon y plus a by 1 minus ay, because this 1 upon y minus ay square can be written as 1 upon y plus 1a plus a by 1 minus ay. So therefore now you can integrate this. So while integrating you get integral of dx by x plus a is same as you can see here, integral of dx by x plus a is nothing but integral of d of x plus a, because differentiation of constant term gives you 0 only. So this will be equal to log of x plus a. And from here you'll get log y minus log of 1 minus ay. This is also the same thing only. Why? Because 1 minus log ay we have here is a dy by 1 minus ay is same as d of 1 minus ay. So you have to put minus sign here so that this minus which comes from here will become plus. So 1 minus ay. So integral of this will give you minus log of 1 minus ay plus log c. Now bring all this term to the right hand side. We have log of x plus a plus log of 1 minus ay minus log y is equal to log c, or log of x plus a into 1 minus ay by y is equal to log c. Now taking exponential, use this because log of a plus log b is nothing but log ab. Log a minus log b here will give you log a by b. So using that properties of logarithm we apply here. After that, taking exponential, e to the power log of something gives you this value only. So x plus a into 1 minus ay divided by y is equal to c, or x plus a into 1 minus ay is equal to c. Y is the solution. So the rest of the problems, it will be the same only. I have solved. So if you have any problem, then you let me know. So that's all.